Hello and welcome to Intermediate Algebra, Unit 6, Lesson 2, Part 1 of 2. We're going to factor trinomials, expressions with three terms that is, with a leading coefficient of 1. That's all we will do for this part of the lesson. So that is our whole lesson objective, to be able to factor quadratic trinomials with a leading coefficient of 1. You'll see an example and understand what that means in a moment. So, first of all, a trinomial is an expression that has three terms. When we say quadratic trinomial, it means there is a term with an exponent of 2, and that's the highest exponent that exists in the expression. So we have ax squared as our first term, where a would be the coefficient or number in front of the x squared. Bx is our second term, where b is the number in front of the x, or the coefficient of the x. And c is our constant term, which is a number without a variable, just a number, you might think of it. So this can be quadratic if either the bx or the c are 0 if they're missing, but it wouldn't be a trinomial anymore. But to be quadratic, you have to have a power of 2 as your highest exponent, and to be a trinomial, you have to have three terms. So first, we're going to look at the case where that coefficient of the x squared term, the a, what we call a, and you'll see this over and over again as you move through algebra, where that's a 1. That's actually the easiest case of this. And really what we're going to be doing is looking at reversing the process by which you multiplied binomials, and many of you call that the foiling process: firsts, outers, inners, lasts. So here's an example. If you were asked to multiply, remember now that's the opposite of factoring, that's the opposite operation. If you're asked to multiply x plus 3 times x plus 5, you would multiply the first term in each set of parentheses and get x squared. Then you would multiply the outer terms, x times 5. X is the outer term in the first set of parentheses, 5 is the outer term in the second set, and you get 5x. And then the inner terms, 3 times x gives you 3x. And the last in the first set of parentheses is 3, and the last in the second set of parentheses is a 5. 3 times 5 is 15. Then you look and see if you can combine any like terms. And the terms in the middle can be combined in this case. So we would have had x squared plus 8x plus 15 is the trinomial we get from multiplying these two binomials. What we're doing when we're factoring is going backwards. We're taking the x squared plus 8x plus 15 and turning it back into these two binomials multiplied. So the general pattern, regardless of what our numbers are at the end, and the a and b can be negative also, is we had this x plus a times x plus b. That middle term became the a plus the b times the x, and the end term is a times b. So if we want to deconstruct that, we want to go backwards. A and b need to be numbers who multiply out to be the last term, in our case it would be the 15, and add up to be the coefficient of the middle term, which would be 8. So 3 times 5 is 15, and 3 plus 5 is 8. That's how we would factor x squared plus 8x plus 15. And that's the general pattern is shown here. So now, what if we want to factor x squared minus 3x minus 10? And notice b and c are negative numbers now, and that's okay. We use them as negative numbers in our process. We need the factors of negative 10 who add up to negative 3. Now when you're multiplying two numbers together to get a negative, one of the factors must be a negative number. So we try negative 2 and 5. So what I've done here is written all the possible pairs of factors of 10. There's not that many ways to get 10 with two integers. 2 times 5 or 10 times 1. And I've accounted for, okay, negative 2 times 5 or a positive 2 times a negative 5, because that's two different ways to get negative 10. 10 times negative 1 or negative 10 times 1. So I add up these factors, and I can see they all multiply to 10, but I need to use the pair in this list that adds up to a negative 3, and that will be this this positive 2, negative 5 adds up to negative 3. So I'm going to have a be 2 and b be negative 5. So I get x plus 2 times x minus 5. And if I multiply that out using my foiling method or distributing the x and then distributing the 2, however you learned it, you will get x squared minus 3x minus 10. But the short way to see that is 2x minus 5x is negative 3x. 2 times negative 5 is negative 10. You check your work in factoring by doing the multiplication and seeing that you get back what you started with. So let's try another one. This time b is positive and again c is negative. So I know one of my factors of negative 14 is going to be positive and one's going to be negative. There's again not too many choices for negative 14. Don't forget about the choice where you have just like 1 in the number. Students sometimes forget that. I write out all the factor pairs that would multiply to negative 14, and I need to find the pair that adds to 5. Now I wrote them all out. You can stop once you find the pair that adds up to what you need, but I wanted to show you the entire process. So negative 2 plus 7 is 5, so I'll let a be negative 2, and b will be 7. So I get x minus 2 times x plus 7. Now if I had done x minus 7 times x plus 2, I would have had a negative 5 in the middle, and that, when I checked my work, if I got a negative 5 in the middle, it would mean I just have to switch my signs. So I check by multiplying, and x minus 2 times x plus 7 does indeed work. So now I want you to try these. The answers are in the next slide. You should stop the video, write down the problem, stop the video, and then try them, and then take a look at the answers. Okay? See you in a minute. Alright, you back? I'm trusting you stopped the video like you really did, and you really did the problems. But here we go anyway. Alright, I get x minus 7 times x minus 3 for problem 1, and notice that the 21 was positive. If I'd used a plus 7 and a plus 3, they would have multiplied to positive 21, but I would have had a positive 10 in the middle. So in that when c is positive and b is negative, you can use 2 negative factors to make that last number. So that's how we got x minus 7 times x minus 3. Negative 7 times negative 3 is indeed plus 21. Negative 7 plus a negative 3 is negative 10. And for the second problem, y plus 1 times y minus 2, 1 times negative 2 is negative 2. I had a negative y in the middle, so that meant I had to use the combination that was negative 2 and a positive 1. And that's not too bad because there's only one way to factor 2. 2 times 1, or in this case negative 2 times positive 1, or positive 2 times negative 1. Alright, I hope that these are a little simpler now. The trick is in being able to factor that last number. If you have trouble with that, use your calculator. Start by writing down 1 in the number. And in this case 21, I'd have 1 times 21. Then see if the number divides by 2. You can use your calculator to do that. If you do 21 divided by 2, you'll get a number after the decimal point. That tells you 2 is not a factor of 21. But when you do 21 divided by 3, your calculator says 7 with nothing after the decimal. You divided by 3 and got 7. That means 3 times 7 is a factor pair that makes 21. You go to 4, you don't get anything. You do 5, you don't get a decimal. You get a decimal, so it's not a factor. You go to 6, and when you go to 7, you're starting to repeat yourself because you already have 3 times 7. You'll just get 7 times 3, so you know you're done. That's the easiest way. The 21 isn't bad. Most of you can do that, I'm sure, but when the numbers get much larger, students sometimes need a process for finding all the factor pairs. Alright, so good luck with that, and I hope you found this video helpful.